स्टूडेंट्स, आज हम टॉपलिंग के बारे में बात करने वाले हैं. बिफोर दैट वी विल सी वन एग्जांपल हियर. See, there is a plain surface here and one bottle is here. Okay, when I applied the force exactly at its geometrical center or near about the geometrical center, it performs the translational motion. Okay, now when we apply at the bottom also, you can see is a translational motion. Okay, now when we apply the force on its top surface, you can see here, it is not moving forward, it is not moving in forward direction, rather than it is doing a toppling. Okay, it is the process by which objects become unstable or fall because shifting of its center of mass. Okay, now how it is happening, we have to see that things. Okay, see, first, when you apply this force, it is not moving in forward. Okay, and when you apply force here, it is moving in forward direction. Okay, before bottle moving in forward direction, the static friction comes in picture, and when body moves, then the kinetic frictions. Okay, that means when body is falling or doing a toppling, okay, it is before starting of the translational motion, or before it's moving in a forward direction. Now there is a question, why we have to learn this toppling? Why we have to learn this toppling? Okay, suppose, consider this is vehicle. This is vehicle. Okay, and this is center of mass of vehicle. This is the wheel, and it is moving on curve path. It's moving on curve path. Then, if force is applied, which force? Because of its motion in circular path, centrifugal force is applied on the center of mass of body, and this is the frictional force. Okay, now this force causes a torque around this center of mass. Similarly, this frictional force also causes the torque around the center of mass. Okay, now the weight of the body acting downward, and opposite to that there is a normal reaction. Opposite to that there is a normal reaction. Okay, to balance this torque or couple, because of this frictional force and this centrifugal force, this center of mass is trying to shift, or this normal is shifting towards away, or we can say outward side. By suppose first it will shift by x1 distance, then x2 distance, by x3 distance. Okay, as speed is increasing, slowly it will get shift towards the this end. Suppose this total distance is x, but this cannot shift beyond the x, beyond the x distance. It cannot shift beyond the x distance. And when force exit more than that, and when force is exit more than that, the couple formed by this frictional force and the centrifugal force is more than the anti-couple applied by the normal reaction of the vehicle, and vehicle get topple. Okay, and vehicle get topple or skidding. Okay, that's why the learning of toppling is important thing. Learning of toppling is the important thing. Okay, see here, we are applying the force F. We are applying the force F here. Okay, when you apply the force F, slowly what will happen? This normal reaction will get shift from its center. Actually this is center of mass, suppose, and this is the q. So this is the h by 2, this is the h by 2. Suppose this is a b by 2 distance, b by 2 distance. Okay, now this force will cause couple, okay, like this, and this force will also cause the couple about the center of mass. To balance this couple, this n applies the couple in the opposite direction. So for that, it has to shift his distance. Suppose x, then n into x1, n into x2, n into x3, n into x3, okay, like this, okay, n into x3. Likewise, total, suppose this is a b by 2. So what is the maximum value this anti-couple can obtain, or balancing couple can obtain, is n into b by 2. So when this value is less than couple formed by this by 2, okay, the vehicle or the body get toppled, okay. That means this n is shifting away from its center of mass slowly, x1, x2, and x3, okay. And this balancing couple value get increased gradually, okay. After that, what happened, at certain limit is there. What is the limit? Because of the length of the body, this, or we can say the width of this body, so maximum it can attain the value is n into p by 2, okay. After that, if we increase the value of the force, if we increase the value of the force, the unbalancing couple is increased and vehicle get toppled, okay. Now we can, either we can increase here f, or either we can uh, adjust the h here. That means you can increase the f, or you can adjust the h value here, okay. But here you cannot change suddenly the weight of the vehicle, okay. You cannot change the suddenly the weight of the vehicle, okay student. I hope the toppling concept get clear to you. Thanks. Hello friends, today we are going to learn a problem from the optics. Here we have a combination problem, biconvex lens and a biconvex mirror. Okay. Now what is the problem statement? A biconvex lens having a focal length 20 centimeter is placed 5 centimeter in front of convex mirror having a foci 15 centimeter. An object of length 2 centimeter is placed at a distance 10 centimeter from the lens. Find the location of three images. The image formed by the lens as the rays travel to the right. The image formed after the rays reflect from the mirror. And the third, the final image after leftward traveling rays once again pass through the lens. Okay, that means we have to find out the location of three images here. Let's start with the first one. Here the biconvex lens f is equal to 20 centimeter, and obviously it is a positive, okay. Now the rays are traveling in right direction, from left to right direction, and object is placed towards the left side. So here we can say u is equal to minus 10 centimeter, and what is focal length? 20 centimeter. That means object is placed in between the optical pole and in between the f. So that means that uh, we will get a virtual image here, okay. Now use the mirror equation. 1 upon v, 1 minus 1 upon u is equal to 1 upon f. Here this formula we have to use. Now simply put the values of corresponding parameters. You will get v is equal to minus 20 centimeter, v is equal to minus 20 centimeter. Here the image you can see here image is erect, magnified and virtual. This is the first image which act as the object for the mirror. Okay, which act as the object for the mirror. Now for the mirror, okay, the distance between biconvex lens and the mirror is 5 centimeter. Now the distance of this first image from the center of this biconvex lens is 20 centimeter. So total distance from the mirror for object is 25 centimeter, and rays are traveling towards the right direction. So u is equal to minus 25 centimeter and f here is a 15 centimeter. Okay, so use the mirror equation 1 upon v plus 1 upon u is equal to 1 upon f. After solving this, we will get here the v is equal to 75 by 8. 75 by 8. Okay, you can see here the image is formed. This is the f for mirror. This is the object position for the mirror. This is optical pole. Okay, and here the center of curvature of mirror is located. So two rays are passing. One is passing parallel to principal axis, then passing through the foci. Another one is passing through the center of curvature, which is not deviating. So here we are getting one diminished image, erect and virtual. Okay, because the rays are actually not meeting. When the rays are coming towards this surface, it is reflecting back. We are extending here and we are getting image here. Okay, next, third. Now this second image act as object for lens again for refraction. Okay, now the f is 20 centimeter positive because of biconvex lens. Now u is 75 plus 8. It is behind the mirror, plus distance between the mirror and the lens is 5. So total distance for the object is here in this case is 115 upon 8 centimeter. Okay, now we use the mirror equation, lens formula. 1 upon v minus 1 upon u is equal to 1 upon f. Here we are getting, after solving this equation, we are getting the total answer is 51 centimeter minus 51.1 centimeter. Okay, just you have to put the values here. 1 upon f plus 1 upon u, you will get the rays are traveling in this direction, so we have to take u as a minus here. Okay, rays are traveling from this right to left direction, and object is placed behind the mirror, so u is minus here, and after that solving this equation you will get one magnified image. Okay, at the distance 51.1 centimeter from the principal focus of the, sorry, from the center of the biconvex lens. Thank you. Hello students, today we have a problem from radioactivity, and statement of the problem is nuclei of radioactive element A are being produced at a constant rate alpha. We have one radioactive element having a name A which have a production rate alpha. Okay, the element has a decay constant lambda. Okay, and the disintegration of that element A is happening at the rate of lambda, which is a constant. At the time of t is equal to 0, there are n not nuclei of the element. Okay, at the starting, when the time t is equal to 0, the nuclei are n. Okay, so first calculate the number n of the nuclei of A at time t. If alpha is equal to 2 and not lambda, means if production rate is equal to 2 times of and not into lambda, calculate the number of nuclei A after one half life of A and also the limiting value of n as t tends to the infinity. Okay, now Here, the rate of production means dna upon dt is equal to alpha. Rate of decay dna by dt is equal to minus lambda na. This is a radioactivity law here. And once we combine both these, we will get net or effective rate dna upon dt alpha minus lambda into na. So to solve this, we have to first arrange the terms, similar terms in one side. So dna upon alpha minus lambda na is equal to dt. Then we have to integrate from initial to final state. So at a final, when the time is t, the number of nuclei are n. So n naught to n dna upon alpha minus lambda na is equal to 0 to 2 integration of dt. Here we can use the formula 1 by x, integration of 1 by x is log x. Here lambda is the constant. Right, we can take it out from the integration. Then we have to put the upper and lower limit. We will get the minus 1 upon lambda ln of alpha minus lambda n upon alpha minus lambda into n naught. Integration of dt is t. Okay, so here if we transfer this lambda towards the right side, we will get ln alpha minus lambda n upon alpha minus lambda n naught is equal to minus lambda t. Okay, next, here alpha minus lambda n upon alpha minus lambda n naught is equal to e raised to minus lambda nt. We have taken, or we have transferred this ln to the right side, we can say here. Okay, so alpha minus lambda n is equal to alpha minus lambda n naught is equal to e raised to minus lambda into t. Again, here we can subtract this equation from this alpha. So alpha minus this equation upon 1 upon lambda, we will get the n present at the time t. At the time t. Okay. Now, what is next? When alpha is equal to 2 n naught lambda, we have to replace this alpha by 2 n naught lambda. Okay, and you have to solve this equation. Okay, you can take n naught lambda common here. 2 n naught lambda minus n naught lambda e raised to minus lambda, and you have to put the t is equal to infinity. Okay, then lambda lambda get cancelled, and naught here e raised to minus lambda infinity becomes a 0, and you will get final answer as n is equal to 2 times of n naught. Okay, then third is when the t is equal to t by 2, that means t is equal to ln of 2 upon lambda. What is the n? So simply you have to put 1 upon lambda 2 n naught lambda minus n naught lambda e raised to minus lambda into ln 2 upon lambda. You have to solve this equation, and you will get n is equal to 3 by 2 into n naught. And this is the end of the numerical. Thank you, students. I hope you are getting this. This is totally a conceptual based problem. Here you have to use the integration, putting upper and lower limit and solving the equation. Concept is very simple. Okay, thank you. Hello friends, today we are going to look a problem from the rotational motion. Okay, here what is the case? One solid cylinder having a mass m and radius r is set in rotation about its axis with an angular velocity omega naught. So initial velocity, angular velocity is omega naught, then lowered with its lateral surface onto a horizontal plane and release. Then after we release this cylinder on one horizontal plane, is first sliding, then we start its rolling motion. We have to calculate how long the cylinder will move with sliding, and then total work performed by a friction. Okay, now first cylinder will do sliding, and then we will start a rolling motion. What is the difference between sliding and rolling here? When we give omega naught as an angular velocity to the cylinder and release it on horizontal surface, its linear velocity v is not equal to the r omega naught. Okay, and when it start a pure rolling, that time this point of contact means when any rotating body like a disc, ring, a spherical body, it's when rolling on a ground, it have only one point of contact between the body and the ground. this point of contact will be fixed in case of rolling. That means when r omega is greater, it will move backward. If v is greater, then it move forward. But when r is equal to, sorry, when v is equal to r omega, it will be fixed and body will start rolling motion. Okay. So first of all, for regarding sliding, the v is not equal to r omega naught, or we can say v of v, the center of mass. Okay, v, because we are considering here forces on a center of mass. Okay, so the v of center of mass is equal to 0. Now from center of mass, one downward force will act, that is the weight mg. Now at the point of contact, when body start pure rolling motion, frictional force will act. Okay, now first of all, when body doing sliding, it have omega naught angular velocity. When body doing pure rolling, it have omega as a angular velocity. Okay, and in case of the pure rolling, it have the linear velocity also, v is equal to r omega. Okay, here we use conservation of angular momentum method. Okay, that means Li is equal to Lf. Okay, where Li is the initial angular momentum, Lf is the final angular momentum. Okay, so regarding the angular momentum of body having the angular velocity, okay, is I omega naught. Initially body having only angular velocity. Okay, then when it start pure rolling, it have linear velocity also. So I omega plus mv into r. Okay, so for solid cylinder, axis passing through its center, value of I is mr square by 2 into omega naught. And here again we can write I is equal to 1 by 2 mr square into omega plus m into linear velocity. We can write v is equal to r omega. So r into r become r square into omega. Now we can cancel the similar terms. Okay, what we got here, omega naught by 2 is equal to omega upon 2 plus omega, which yields the final angular velocity omega is equal to 1/3 of the initial angular velocity. That means when v is equal to r omega, it start pure rolling motion. Okay, up to that it will do its sliding motion. Up to that it will do its sliding motion. Okay, now we have to find out angular retardation. Okay, because of the frictional force. Okay, now we are seeing here the angular velocities decrease. Now what is the reason? Reason is the retardation caused by frictional force. Okay, frictional force. This frictional force act will produce a torque which act anti-clockwise. Okay, which act anti-clockwise, and body is moving in clockwise direction. Okay, so we can write I alpha is equal to mu mg. Mu is mu into mg, that means mu into normal. Okay, into r. Okay, into r, which gives you here the alpha is equal to 2 mu g upon r. Basically this alpha is a minus 2 mu g upon r because it's a retardation. Now we can use equation of motion, omega final velocity, omega naught initial velocity, plus alpha into t, that means v is equal to u plus at. You are getting here value of t. For that we have to first replace this omega by omega naught by 3, then omega naught minus 2 mu g upon r into t. Okay, after solving this you will get a equation, and final answer is t is equal to r omega naught upon 3 mu g. This is the time we got here. We got alpha, we got time also. That means we are ready to calculate the s. What is the s? Okay, we don't want to calculate the s here, only we have to find out the time. Okay, that is fine. Okay, then to find out the work done. Okay, how to find out? This is the initial energy, this is the final energy plus work done. Okay, initial energy is 1 by 2 I omega naught square is equal to final energy 1 by 2 I omega naught square, then 1 by 2 mv square. It is a rotational kinetic energy, it is a linear kinetic energy, and this is the work done. Again, we have to just put the values. I is equal to mr square by 2, I is equal to mr square by 2, v is equal to r into omega, and after solving this total, okay, you will get the value of work done is mr square omega square divided by 6. Okay, so mainly the concept is important, and mathematical calculation you have to do very carefully. Okay, friends, thanks very much.